Yes.
All right, so a couple things I want to mention off the bat. So, how many of you have like a physical iClicker? Have you registered it on Canvas? Everyone. So I'm not. It's for some reason not syncing up the names. I can do it manually for now. But if you wouldn't mind, make sure that you've clicked on that iClicker registration, which is down here on Canvas, and kind of try to re-register those iClickers. Hopefully I can get them to kind of link up. Otherwise I can manually go in and kind of enter grades. It's not a big deal. Because I still have you recorded, but for some reason it's not matching up the names to I can see the iClickers in there. I can see the numbers. So I may end up having to just get the numbers from each one of you, kind of have you all send an email, and then I can manually match up that way. But try doing it on Canvas one more time. Maybe it's something about when I synced it versus when you guys entered it. We'll see if we can kind of get that working moving forward. The other thing I want to mention was on that individual assignment. So, I'll show you on the first Excel homework. Excuse me. So, I think question 4 said something about, where is this at? Said something about calculating means for 2 different groups. So I didn't explicitly show you how to do this in Excel, but I'll kind of give you an idea about what I'm looking for there. So I'm just going to select my entire data set here. This is the first Excel homework. It doesn't matter what data I'm using, just kind of showing you as an example. I'm going to go to data, maybe data, and then filter. So I can filter this. So I'm going to go up to the top. Maybe I want to do what I want to do here is like look at only the average number of votes that either one of these candidates got in Alabama. So notice I can sort, if these weren't already sorted, I can sort from highest to lowest, or I can sort obviously kind of highest to lowest in terms of alphabetically, right? It's going to go Z to A or A to Z. So maybe I say, okay, I just want to know the average in Wyoming. Well, if I've sorted this data, right, I can find the average, I don't know, Trump votes. And then I just scroll down or kind of select down to wherever the very last Wyoming kind of observation would be. Now I've got the mean in Wyoming, and then maybe I want to do the mean in Wisconsin. I could just take the average and then just select quite a few more of these, right? Just select the Wisconsin ones. It's going to put that reference in there for me. And now I've got 2 means based off of 2 different groups in this data set, right? So just the average here to different states. So it's going to look a little bit different for everyone's data, but basically you're kind of going to sort your data set based off 1 variable and then find the average for kind of 2 different groups.
Can it be like the same, like, can it be like that, the same?
Yeah, the same variable. Yeah, so you're finding the average or the mean of the same variable. It's just you're only really selecting a portion of the data, right? And in this case, you're just selecting Wisconsin or just selecting Wyoming. And there's more complicated ways to do it, but I kind of just getting used to using that filter tool and thinking about sectioning the data off using that filter tool, okay? Any other questions before we kind of jump into material here today? Excuse me. Okay. So that individual assignment is due by the end of the day today. If you have any last minute questions, feel free to kind of shoot me an email. I'll try to respond as quick as possible today. Hopefully at least started kind of working on it.
Yeah, sort of a personal question, but would percentages be considered discrete or continuous?
So probably continuous, right? Because there's an infinite combination of numbers, right? 8 over 13, 8 over 1,341. Yeah, okay. So technically, we want to think about percentages. You could have it out to whatever decimal you want. So yeah, think about that as continuous. Yeah.
Like label on that question, like what we're studying, what we're showing the data of.
Mm-hmm.
Like, do we should put the numbers in, or you want us to like say like what the numbers mean?
Oh, so when you're uploading these individual or Excel assignments, always upload your Excel file so I can see the work that you did. In Excel, don't just like put the number in a Word document, right? So kind of you want to summarize it in a Word document and say, here are the 2 means that I found, that's fine. But really all I need to do is see it in that Excel file. So if you've done something like I just did, you upload that Excel file, There's no other explanation that you really need there, unless I'm asking you like to compare them or something like that. So you should always kind of be uploading your Excel file. And if you want to kind of have the written responses in Word, you can upload multiple files. So, you know, some people don't like to type things out in Excel because then when I click out of the cell, if I had something here, it kind of cuts that off. And so sometimes a lot of people just like to type things out in Word. I don't care. You can type it out in Excel as well. I can click on, even if it's hiding, as soon as I click on that cell, right, I can see everything that's inside of it. Right. So you can type it out in Excel or kind of type out in a separate Word document and upload both of those. Any other questions? Okay. So that should take care of that. We left off thinking about the variance, the standard deviation. I kind of walked through how we calculated, but we didn't really work through any examples. So today we'll work through some examples doing it by hand. But really what we said was the variance, right, was going to be, let's get that, there we go. Treated differently for populations versus sample data, right? We said the process is exactly the same. We go through every observation, take the deviation from the mean, square that, do that for every observation, then add them all up. For a population data set, we then divide by the number of observations we have. For a sample data set, err on the side of caution, overinflate that sample variance a little bit. We're always going to divide by n-1, the number of observations -1. So we then said the standard deviation is just basically the variance, but we have one more step, which is to take the square root. We're just scaling it for some other uses down the road. Okay? So what is this going to look like by hand, right? So I've got kind of this old Ball State football coach data set. It's kind of nice. It's got 10 coaches, kind of makes like the number of observations easy. You can kind of think about this as, you know, maybe the head football coach is like a CEO, your mid-level kind of managers, I don't know, the video tech guys like your janitor, right? You can have this nice variation in salary here. Now I kind of just cut off the zeros. This is in thousands, but just makes the numbers a little bit easier to display and to deal with. So what would I do first? Well, the first thing I need to know is if the variance is like the average deviation from the middle part of the data, well, I need to know where the middle part of the data is, right? I need to know the mean. Okay. So we'll treat this like it's population data just to make it a little bit easier to start out. So I've got 10 observations. All I'm going to do to find the mean is add these values up and divide by the number of values I have, which is 10. So go through, find that mean, right? That's just taking every single salary that I have there, add them all up, divide by the number of salaries I have. Should be pretty easy. Now that I've got the mean, I'm going to go through every single observation, take that observation's value for this variable x, right, salary, subtract that mean of 134.5, and then square that value. And what I could do is just create another column, right? So I took that deviation from the mean, squared it, write that number down. Go to the next person, 150,000 minus the mean of 134.5, square it, write that number down, right? Now I do that for every single observation. Once I do that, I would then add that column up, right? That would be the sum of my deviations squared. And then to kind of make this like the average deviation, it's just like when we're calculating an average, once I add all those up, I then divide by, oops, the number of observations I have, right? Divide by n. Okay? So if I write that all out, and do this all in one line on my calculator, it's going to look a little nasty, right? Because what I'm doing is taking every observation's x value minus the mean, squaring it. Add to that the next observation's x value minus the mean, squaring that. I have to go through and do that for every single observation. So when I write it out, it's going to look kind of nasty. And sometimes I'll start doing this just to kind of get used to it. Instead of dividing by 10 here, I put the whole thing in parentheses and said multiply by 110. Right, so dividing by a number is the same as multiplying by 1 over that number. And I just did that here because I had this on multiple lines. I thought it divided by, it would kind of look weird. But also I'm going to start kind of some of the things that we're doing. We're going to start pulling out, right? We're dividing by n, we can pull that out and say it's the same as multiplying by 1 over n. So if we do that, we get about 14,700. Right? So that's how we would calculate the variance. Now, like I said, in practice, what I would do is probably create this additional column where I, instead of typing this all in one line in my calculator, which if you're comfortable with, go for it, fine, right? As long as you get your parentheses correct, right? But you could kind of break this down by observation, writing each kind of deviation square down, then adding them all up. And then we had one more step, which is then I need to divide by the total number of observations I have. Okay. Any questions on this before we keep going? Come back to this slide. Skipping kind of the, so maybe a little bit of kind of a reminder of what we did last class. So, or some of the things we talked about. I'll start off with hopefully, I think, an easy one. That's fine. So instead of answering this question, I have a different question I want you to answer. Okay? So if I'm looking at this data set, just to kind of get behind what the variance actually is, which of these values can I rule out for sure, right? So don't calculate the variance. I'm asking you which of these values, just looking at that data set, can you rule out as being the value for the variance, right? Just give you time for 15 seconds here to think about that. So the question I want you to answer, which of these values can you rule out as the variance of this data set? Remember, the variance is the average variation from the middle part of the data. Okay. So if you don't have an answer and take your best guess here, you're just answering which of these can you rule out as being the value for the variance. So we got 13 of us here. 3. I think I'm missing one. 1, 2, 3, 4, 5, 6. Oh no, we got 14. All right. So which of these can you rule out right away? Why? What would a data set have to look like if the variance was 0? Everything would be the exact same. Not a trick question. I'm just trying to make sure that we understand the principles behind what we're doing. From there, if I wanted to actually calculate the variance, what would I need to do? Well, first, I need to know where the central point of the data is. I already got that up here. That the mean, or that mu, that Greek letter, the population mean, is 45. I would then go through every observation, take that value, that observation after x, it's mean times 20, subtract the mean of 45, negative 25 squared. Maybe click on here again. There we go. There we go. So negative 25 squared. Right. Negative 25 squared minus 625. Is this? Yeah, I guess it is. Okay. Anyways, all right. Never mind. My mind's not moving. All right. So 20 minus 45, negative 25 squared is 625. 35 minus 45, negative 10 squared of 100. We're going to continue to do that for every single observation. I then have my deviation squared for every observation. Well, the variance is the average deviation squared, right? Or the average deviation from the middle part of that data. So we'll add all these deviations up and then divide by the number of observations that I have, right? Just like when we're calculating the mean, we divide by the number of observations that we had. We're kind of getting that average value. Here we're getting the average deviation. So, if instead, and this usually wouldn't be the case, but let's say I treat this like population data, and then someone comes to me and says, no, this was a much larger company. I just gave you a subset, right? There's actually like 700 employees. I only gave you 7 of them. So you go, okay, so when I'm calculating this variance, I really should have been calculating a sample variance. So if instead, when I calculate the population variance, I get 414, if I were to calculate a sample variance, which of these answers would have to be the sample variance? So I'll open this up, kind of let you think about this, right? We just calculated this like it was a population variance, and I found 414. If I want to calculate a sample variance, without even calculating it by hand, I know right away one of these has to be the correct answer, right? So remember, the only difference between a population and sample variance is we divide by n-1 instead of n, right? So which of these answers would have to be the sample variance? I'll give you a little bit of time to kind of give you your answer to that so I can see where we're at with our understanding. Which of these, we don't even have to work it out by hand, just knowing the fact that we're dividing by n-1 instead of n, what would have to be true about the sample variance once I calculate, or which of these would have to be the sample variance? I'll give you guys another 10 seconds and we'll close it out at the minute mark. All right, everybody get your answers in. Still need 2 of you, it looks like. 1 of you. All right, everybody, all right, there we go. So, which of these has to be the sample variance? Yeah, why? Yeah, if I'm dividing by n-1.
Glad you read my mind.
I'm gonna divide by 6 instead of 7, right? So if I go back here, I'm doing the exact same process. All the deviations from the mean squared are gonna be the same value. So they're gonna add up to 2,900. It's just that instead of dividing by 7, I divide by 6. Dividing by a smaller number is going to increase, right? We're always erring on the side of caution when we calculate that sample variance by dividing by n-1. We get a slightly higher variance. Now, like I said, in practice, you're not going to be calculating the population sample variance for the same data set, right? You should only be using one of them. I kind of was just using this as like, oh, if I treated it incorrectly and then found out it was only sample data, and what would that look like? Okay. So I had this old slide. I'm probably just gonna go through this quick because I'm not gonna quiz you on it, or kind of expect you to even know it, but I'm showing you this is the way that we calculate a sample variance. And the reason why is because I think it's easier and it connects more with what the statistic measures. It really is this average kind of deviation from the middle part. I can rewrite it to look something like this, which maybe is easier if I'm doing this by hand, right? Because now you can kind of imagine in Excel, I can just create a column where I just took all the x values and squared them, then add all those up, right? We're going to use that sum function. We can add up a bunch of numbers really quick, even for like 100,000 observation data set. Easy to find the mean, easy to find the number of observations. We said we'll use that count function, right? Just to get the number of observations. So maybe it's a little bit easier if I'm kind of breaking this down into steps, right? But anytime I tell you something is the same, you should be like, well, these look pretty different. How did I get there? Well, you can actually walk through a mathematical proof, right? So you start out with this equation, kind of FOIL the numerators, and write all that out. So we're just going to deal with the numerator for a second. So I write out those components, and I'm summing up something. I can distribute the sum, right? And then here's where it gets kind of cool. This is why I can never do a true mathematician. They multiply these two things by 1, right? Multiplying by n over n. N over n is 1. Shouldn't change anything. We then rearrange things. I'm adding up constants. I can pull those out. Right, so I can pull all that out. Now I get the sum of the x's over n. That looks a lot like my mean. Things just simplify down, right? I'm never going to expect you to go through this. There will be mathematical proofs that exist for a lot of things to do in class. And I'll just tell you that if you want to talk about them or look at them on Google, you can. But right, we're not going to kind of walk through them step by step like this. Right? But there is a proof that says these two things are going to be exactly the same. So typically what I'll do, right, instead of walking us through these mathematical proofs that even I have to kind of go back and remember the laws of kind of summations and how you can rewrite things. I'll just show you with data, right? So we have that exact same data set. I'm just going to go through, calculate the variance using this formula. I'm going to show you they end up being the same thing, right? So I'll tell you a mathematical proof exists, but usually I'll just show you with the data set, right? So if I take all the x values squared and I add them all up, right, so the sum of my x's squared, that was one of the components that we needed. I've got that value. You can see it moved over, but this is my mean, right? I had the mean before, so that's pretty easy to calculate. I can square that mean pretty easily. I've got 10 observations. I've got my mean squared. I can plug in. I've got the sum of my x's squared. That would be kind of what's in the numerator there. The only thing left I have to do, just like before, divide by the number of observations, and I get the exact same value. So I calculate it the other way. Now, you can calculate the variance this way. Like I said, I think it's easier to do the other way. More specifically because it really connects more with what that statistic's actually measuring. I can't really see, so I showed it to you this way. This isn't quite as clear that I'm picking up the average deviation from the middle part of the data, right? That doesn't that's not how I would interpret that formula. So, you know, usually a little bit easier to kind of deal with the other one. Always good thing about like, I'm looking at income values here or salary values. Notice when I was squaring those values, I'm getting really, really large numbers. And that's even after I drop the zeros here, right? Whereas if I look at the deviation from the mean squared, well, now 489 minus 134, it's a smaller number. So when I square it, I'm not dealing with as large of numbers kind of in the intermediate. So it's probably easier to kind of use that first formula I showed you. To be complete, you know, there is another way we can calculate it and we'll end up doing the exact same thing. Okay. So we already went through these. Excuse me. Any questions or anything there before? So what do I want to make sure we get through today? So I'll show you this. This applies to the first kind of Excel assignment. So I'm going to go back actually and open up that enrollments file that we've been working on. Okay. And this isn't going to be anything too crazy. I just want to show you. So I showed you the mean, the median, the mode last class. Let's do population variance, population standard deviation, sample variance, sample standard deviation. You could use any data set. I'm just kind of showing you the functions, and there's the slide that kind of has them all together. But just like we can calculate the mean, the median, and the mode pretty quickly in Excel, I can do variances and standard deviations as well. So var.p is going to be calculating a population variance, right? Variance.p population. All I do, select the data. So I go over here, select my undergraduate enrollments, Control Shift or Command Shift on a Mac, hit the down arrow, hit enter, will automatically close the parenthesis and send me back up. So very large value here, right? A lot of variation in this data, right? So once again, that built-in function is just var.p, and then I'm selecting the variable I want to find the population variance of, okay? What if I wanted to do the population standard deviation? So that's going to be stdev.p. I think on the slides even, I still have it as std.p. They kind of renamed it for obvious reasons. But now it's stdev.p, and then you select whatever variance. Well, I mean, that is what it was, and I'm sure they changed it for that reason. So if we select that column now, we've got our population standard deviation, our population variance pretty quick. Now, what's another way I could have done that instead of just using that built-in standard deviation function? All right, so instead of using stdev.p, what I could have done if I already had the population variance is what? Just take there was one more step to go from the variance to the standard deviation. That's the square root. So that was one more step to get from the variance to the standard deviation was we took the square root. So the built-in function that represents taking the square root in Excel is sqrt. All right. So sqrt just says whatever I select this value, I know you have to type it in. I can just click on that cell that the value is in. It'll take the square root of that. So hopefully what I've told you is correct. And these functions are programmed correctly. When I hit enter, I'll get the exact same value here for my population standard deviation. And it looks a little bit different, but that's just formatting. So one of the things you can do in Excel up here, nope, right here is where it moves the decimal for you. So notice I can kind of round it to the integer, or I can go out as many decimal points as I want and have it display more and more of them to me. Now, I don't know how far out this actually goes. We could probably go out 20 decimals. It's just kind of only showing you the first four.
What is the population again?
Yep. So just stdev, right? So standard deviation.p, right, for population. So if instead I had sample data, so usually you would be calculating one or the other, right? Population variances or sample variances. I'm just showing you with the same data just to make it all in one place here. It's the exact same thing, var.s though, right? So var.s will give you the sample variance, and then stdev.s will give you the sample standard deviation. So what should be true if I instead calculate a sample variance is it should be a little bit bigger, right? So yeah, 153 goes to 156. Once again, stdev, now we'd be using .s for a sample, right? We could select that variable, hit enter, and now we've got our sample variance and our sample standard deviation. Once again, we could use that SQRT built-in function just to double check that if I take the square root of the variance, it's going to give me the same thing as that built-in standard deviation equation. Sure enough, it does. Once again, if it only displays it to a different number, we could go up here and kind of make sure that, oh yeah, it actually is the exact same value. It just wasn't displaying the same level of decimals. Questions? I know I went through it kind of quick, but I've got those functions on the slides. I'll post up an updated version of that enrollments file on Canvas that kind of has these kind of worked in there. So let me actually just save that so I can upload that after class. That should be everything you need, the last things that you need to get through that first Excel assignment. We already done the histogram stuff. I kind of showed you the mean, median, mode equations. Those would be the only other equations that you need to answer every single problem in that first Excel assignment. Okay. Any other questions before we go back out of Excel here? Okay. So, let's go. So here's that Excel file. I'm going to move this up one so we can start here. So I want to start thinking about how do these mean and variance values relate to what we're looking at with frequency distribution, right? So we already talked a little bit about kind of the idea of left and right skewed and kind of looking at the mean and the median last class would tell us what type of skew we have. But if I think about what's the mean doing to the distribution of my data? So let's say, I don't know, I've got something like female height, and I've got kind of a nice and normal distribution. I graph out the frequency distribution, right? In reality, this might be like a bunch of different bars, but if I'm drawing kind of the line that best fits them, I might have something like this, right? So if I'm looking at male height instead, and I know that male height follows a normal distribution, and let's say it has the exact same variance, right? Then if I'm looking at male height and it's got a higher mean, all that's going to do, right, is shift that distribution, right? So mean changes will just shift my distribution along that x-axis, right? Now, I tried to draw these. It looks like I did male height a little bit higher, but I try to draw them to be the same kind of height there, right? Because what instead we think about not how does the mean change the distribution, but what if we had two groups, we'll say male and females again, because it's a pretty true example. And they have the exact same mean, right? So here I've got kind of the mean for females, and this is I could think about if I look at IQ measures, the average or the mean IQ for males and females is almost identical, right? But what ends up being true is that males are just generally more volatile when it comes to like any biological marker. And so if we're looking at IQ, female variance, let's say it's 100, male variation is much higher, right? So maybe, I don't know, the variance for male IQ is like 200 instead of 100, right? So how does this change the shape of our distribution? Well, it's still centered around the same value, like the mean female IQ and the mean male IQ is the same, right? But what we end up with is distribution that's a little bit flatter, right? So if I'm thinking about kind of this red line, this is kind of representing the male distribution of IQ. If we have higher variance, there's more variation in the data. So what that means is if I'm going to a higher variance, the values near the mean become less likely, right? These frequency distributions, remember, they're frequencies, how often we see these values. And a higher variance means that seeing values further from the mean become more likely, right? So higher variances kind of flatten this curve, making the tails fatter. More likely we see observations out kind of further from the mean, but make it less likely we see values near the mean, right? So higher variances, flatter curves. This is a nice one that kind of set it up, right? The lowest standard deviation or lowest variance is this blue line. The highest is this kind of gray line. You kind of see as we increase the variance or increase the standard deviation, we get a flatter and flatter distribution. Okay. So the mean shifts it along the X and Y axis, and then kind of the variance kind of changes the height, right? Or kind of how spread out that distribution is. Okay. Any questions on that before I keep moving? A little bit of time. We'll kind of dive into this idea of weighted means. Okay. So I don't know how far we'll get on this today. Probably through the means. We may not get to weighted variances, but we'll for sure finish that up kind of next Wednesday. I may end up kind of pushing that due date on the Connect assignment up a class, just depending on how quickly we get through things on, or how much we get through on Wednesday. So before, and I kind of already alluded to this, right? I wrote it out a little bit differently, where we said we can think of what we were doing with the mean as treating every single observation equally, right? So if I have the sum of my x's over n, I said another way I could think about this is every observation is being weighted by 1 over the total number of observations, right? It is 1 out of the total number of observations. But if instead I've got group data where each observation maybe represents a different number of people. So think about it this way. If I want to find the average income in the US, but I only have like a data set that has the average income in every state, I wouldn't want to simply add up the incomes, right? The 50 different income values and then divide by the number of states 50. Why? Because the average income in Delaware represents way fewer people than the average income in California, right? Those two values should not be given the same weight. One of them represents a much larger percent or proportion of the overall country, right? So the other example I used to use to do this is like, if you wanted to find average fast food sales, but you only had it by company, you wouldn't want to treat Jim's Burger Shack the same as McDonald's, right? McDonald's would represent a way higher number of stores than kind of a local establishment, right? So when we have group data, we're going to have to calculate a weighted mean, okay? So the way that we're going to do this, and it's very similar to what we're doing before, but now we'll go through every observation, and instead of just taking the value for that variable x, we're going to take that value, whatever that group is. So in my state example, this might be like, take Delaware's average income, then multiply it by what you want to use as a weight. In my state average income example, what would I probably want to use as my weights? Each state represents a different number of people, so I probably would want something like the population of that state, right? Or the number of working adults in that state, right? And I would want to use those as my weights. So I'd go through every single state, take its average income, multiply it by its population. So the next state, take its average income, multiply by its population. Once I do that for every single state, right? Add them all up, right? That summation sign. Start with the very first observation, go to the last. Do this for every observation and then add them all up. Now, after I do that, what I'll then do is instead of dividing by the number of grouped observations I have, so instead of dividing by 50, well, I'd want to be dividing by the total number of people in the US, or I would add up my weights there, add up all my populations. Okay. So try to go through a different example and try to get at what we're doing here with weighted means. So let's think about something like this class, right? So let's say we've got type here. Wait. And just to make it easier, I can't remember the exact numbers between this class and others. So hopefully this is about right. But let's say we have, I'll make it easy. So let's do 50%, 30% participation or iClickers or whatever, 20%, right? I know this isn't exactly what this class is, but you kind of get the idea, right? We've got different categories. Each of them carries a different weight. So how would we find our weighted mean, right? I'm going to have a score in each one of these categories. So maybe I don't do very well on the exam. Maybe I do pretty good in the homeworks and I show up and get a lot of the points on my participation. Well, this 65 is going to influence my mean a lot more than this 90, right? Because it's being weighted a higher amount. So really what ends up happening is I go through every observation. I take its weight multiplied by, here's my variable X, the score that I got in that category. So 50 times 65 plus 30 times 85 plus 20 times 90. Right? That would be the sum of my weights times the value in that group. In this term, group is different either exams or homework. And then I would divide by the sum of my weights, which here, the sum of my weights should just be 100. Right? So what does this do? If I write this out, and I'll get out of the way in just a second. Okay. So I just wrote out basically that formula for these numbers. This should give me my weighted mean. But another way of thinking about this is, well, remember, these are the different values that I had in each one of those categories. I could actually rewrite this, that for that value of 65, the weight it was carrying was, well, it was 50 out of the 100 possible percentage points in the class, right? And then for this second value, and here I'm just running out of room, so I'm just writing underneath it. I would take the value of 85, and it's 30 out of the 100 possible points. And then I would take that score of 90, it was 20 out of the possible 100 points, right? So in doing this method, what we're really doing is it's like we're creating weights for each one of these categories, which is how many, what was the weight of this first category divided by the total number of kind of, I guess the total of the weights, right? Or in terms of here, how many points out of the total points in the class, or how many people out of the total population, right? So it's kind of built in, if we rearrange it, we're really kind of assigning these weights to be whatever fraction of the data that group is. In this case, whatever fraction of my possible points comes from that category of exams. Okay. Are we on time? All right. Questions? We'll keep moving. I'll go through a couple more examples. I'll go through some examples here. So, the steps we go through: multiply every single group's X value by its weight, add them all up, add all the weights together, and then kind of take those sum of the weights times the X values and divide it by the total sum of my weights. What's this look like? All right, so here I've got some data. I pulled this from the Bureau of Labor Statistics. And I think this was the last, they don't have the new census, so this is like 2010 census stuff. You can get some preliminary 2020 data, but I just grabbed this because it was it's all there. So they have kind of a they break rates down into 4 major categories. Obviously, we could break this down to be much more finer categories here, but this is the way that you can kind of get the data from them. And so I've got kind of by race and by gender. You can kind of see what the average incomes were from this huge data set that they have. They just don't let you see like the original data. So like this is the government Bureau of Labor Statistics. So they're collecting this data. They have like every single person, their income, their race, their gender, all these other where their region they are in the country, but they won't show you that data, right? They'll only show you the data grouped by these characteristics. Okay, so I can't see, person 351's income and all these other characteristics. All I can see is kind of averages by these groups. Okay? So if I wanted to calculate the overall mean income for males and for females, what would I do? Right? So the first thing I would do, if I want to calculate the average income for males, is I've got my first group, right? That mean income of 59,000 represents 74,000-ish people. Was, the value down here of 36,000 only represents 17,000 people. So I don't want to simply just add these 4 values up and divide by 4, because that'll be treating it as though there's an equal number of people in each one of these racial categories. And I can kind of clearly see from these frequencies, I've got a lot more white individuals in this data set than from the other 3 kind of racial categories. Same kind of thing for females here. So I would go through, right, in each group's weight, or the number of people in that group, multiply it by the average for that group. And that's this here. Then I add to that the next group's weight times its X value. I have here. And the next group, and the next group. Right? So once I add those 4 up, I then divide by the sum of my weights over here. I was using this number of people, or the frequency of my weights. Well, I added this up here, I had the number up there for you, right? So you could add up all those frequencies, or what they should add up to is that total of 108,000. So you can kind of break this down in steps. You can type it all out at one time. Like if I'm doing this by hand, I'd probably just add the weights up so I have one number to deal with here instead, just to make it easier when I enter it in my calculator. But the numerator, right, you could as well, just like we were before kind of with the variance, you could create another column where you take, 73,000 times 59,000, write that number down. Then 11,800 times 38,000, write that number down, right? You kind of break this into steps if you wanted to make it a little bit easier to do by hand. So if I do the same thing for the female, I could go through the same process, right? Take the frequency, multiply by the income, add to that the next social group's frequency times their average income, and go through and do that for every single group, and then divide by some of my frequencies there as well. You kind of see here playing out a little bit of evidence of this idea of the gender pay gap. Okay. So I don't have the original data. I can't see this individual line by line observations. I've only got group data. This is the best we can do to calculate the mean, right? Is to come up with a weighted mean. Okay. Any questions on this before we keep moving? So one thing that we'll kind of notice here, I think we've got a question. I won't use it as an unclear question since we've already had a few today. But let's say instead of by race, right, I wanted to get this by characteristics. So now I've got gender and kind of region of the country, right? So which of these regions is going to influence my weighted mean the most? No matter if I'm looking at males or females. Yeah, the South. Why? They have the most people, right? And that's what I'm using as my weights, right? So if we're looking at these different groups, that value of 35,000 should influence my mean a lot more than the value of 37,000 here, right? Because the Northeast has a much smaller number of people. Or think about it here, when I'm calculating the average in the US, right? My white category was going to have much stronger of influence than the Asian category, right? Because the frequency in each one of those racial groups was significantly different, right? Or the weights, the frequencies were my weights there. So if you wanted to, you could go through, and I gave you the answers here. I think in the skeleton slides, maybe there's like a white box over that. So you just click on it and move it. So sometimes I'll have kind of have these animations set up. So opening it up in PowerPoint, if you're able to, allows you to kind of see that there might be some white boxes there you can move, kind of see what the actual answers are. So you can go through and do this same process that we're talking about with kind of doing it with race, right? But region, so 19,000, 37,000, was 24,000, and 37,000, 40, and 35, so on and so forth. And I divide by the sum of my frequencies there, or the sum of my weights, to that 110,000. Any questions over this idea of calculating a weighted mean? Yeah.
Are we always supposed to assume like the multiple categories of numbers that we're supposed to do weighted mean as opposed to not weighted mean? Like, is that?
So you would have to be told something like you have group data, right? That you're, or, you'd be asked to calculate a weighted mean, right? Not, generally a good identification of this though, is if you have two variables where one of them is what you're trying to find the mean of, and you can kind of see this other one is going to represent usually some type of a frequency, right? Which is why I used it. It doesn't have to be a frequency. It could be the total points or the number of points from each category out of the total points. But it'll be pointed out that it is group data. And that once you have that group data, I need to be using something as my weights. Any other questions? Actually, I'll give you one more example. So let's say, and it's like a very basic example, right? But this is the idea of weighted mean. So let's say I was investing in some stocks, see a 10% return, and I see a negative 20% return. I've only invested in two different types of mutual funds or stocks. So if I'm thinking about what's my average return here, well, if I don't have any other information, I just find the average of these two, right? So it'd be what? Negative 5% is kind of my average return. But what if I told you that I invested 900,000 in stock A, but only 100,000 in stock B, right? Well, then my average rate of return, right? That 10% was for 90% of my money invested, while that negative 20% loss, right? That was for a much smaller $100,000 investment. So here, if I wanted to know what my average rate of return is, I really should be thinking about, well, unless I've invested equally in all these stocks, I really should be using the amount I invested as my weights, right? And now here's kind of an easy way. How would I find this weighted mean? Well, I've got my 10% return times how much I invested in that stock. I've got this negative 20% return times how much I invested in that stock, divided by the sum of my weights. All right, looking something like that. You can kind of see here, well, the way I'm weighting this return is it was from 900,000 out of the total $1 million I invested. And then this negative 20% return, well, that was only 100,000 out of the $1 million that I invested. And so we're kind of treating those two investments, you know, according to how much we invested or kind of what proportion of our total investment we had in each stock. And you can make this more complicated by just adding more in here. But even just with two, you can kind of see, you know, if I do it this way, I don't know what number I end up getting. What would it be? But it's definitely going to be positive. Whereas if I just treated this like I invested the same amount in each one, I said I had like a negative 5% return. But because I had way more invested in the one that had a positive return, that's going to influence my weighted mean a lot more than this negative 20 because I didn't have hardly anything invested, relatively anything invested in that stock. Questions on that? Yeah. Why is this one the weight? Because I'm interested in finding just my average return, right? I guess if someone instead said across these 20 stocks, what was the average amount you invested in each one? Well, it's a different question, right? Then I would just look at the average that I invested. But here I'm wanting my average rate of return. But I know that every return, right, will end up being a different amount of money, right? 10% of 900,000 is way different than 10% of 200,000, right? So there I was interested in what was my average return on my portfolio. I've got two stocks in a very interesting portfolio, right? If I wanted my average return for that portfolio, then each return is going to get weighted by however much I invested in that stock. Other questions on that? So, just like we can do weighted means, we can do weighted variances as well. We'll pick up on this on Wednesday. I think I'll kind of do some group stuff. Should be the last couple of questions that are on your Connect homework. And then we got a few more things to kind of finish up until we jump into the next chapter, which is probability. So we for sure should be doing that next Friday. So over Labor Day weekend at some point, maybe even today, I'll get up that next kind of smart book. If you want to do it, you don't have to do it. They're not for any points. You'll see that kind of show up on Canvas because we'll probably start with probability, the next chapter, next Friday. Okay. All right. If you have any questions for me on the way out, feel free to stop up here. Otherwise, have a fun, safe holiday weekend, and I will see you guys on Wednesday. All right. We don't have class Monday.